Hi everyone! I hope you're all enjoying ICFP 2021 and its co-located events, including the ML workshop. My name is Annalita Vante. I am a master's student at McGill University, and today I will be talking about a data-centered user study for jsCoq. I would like to start this presentation by asking the following question. Are the tools we use to write proofs any good? And what exactly do I mean by good? According to a NISTA paper from 2006 from Marat Bosharnitsen and their collaborators, there are three principles for designing a good tool, at least when we talk about tools for writing code in imperative languages. The principles are the following. First is applicability. That means the tool should be able to support real-world applications. The other principle is about scalability and performance. That means when you come up with a production-ready application, your tool should be able to continue to support you the same way it would support if you're just writing a toy application. And the next principle is about usability, which we're going to discuss in detail on the next slide. According to the same authors, when we talk about usability, at least usability in programming environments targeting imperative languages such as Java, there are three main directives. The first one is that the tool should be intuitive to use regardless of the user's expertise level. That means a beginner should be able to use the basic functionalities of the tool the same way an expert is capable of using them. The second aspect is about an integration with a pre-designed workflow. For example, when developing a web application, it is expected that the user is going to write some code, refactor it, and push it to production. That's a pre-designed workflow, and the tool should work according to this kinds of pre-designed flows. The third directive is about support refactoring. So that means your tool should be able to help you to rewrite some portions of your code. Since the tools we write are also programs, it is expected they will have issues, and user studies are a good way to detect usability problems. There are basically two categories of user studies we can think about doing. One of them being based on qualitative research and collecting metrics from small groups of users. For example, we interview a user and ask how they feel when they use a certain tool. The other way we can think about is creating or formulating hypotheses and confirming them from large data sets. These two methods have been applied to tools targeting imperative languages. What about the usability in user interfaces for theorem provers? At this time, there are some studies who target qualitative research, but when we talk about creating hypotheses and confirming them from analyzing large data sets, it looks like we can't do it because apart from GitHub and open projects on GitLab, we don't really have any other open large data set of proofs. So in this talk, we're going to show you how to actually build one of these large data sets using jsCoq, or better saying, a modified version of jsCoq, and which hypothesis one could try to extract from such dataset. If you're not familiar with jsCoq, it is an online interface where you can write your Coq programs directly from your browser. You can give it a try by hitting jscoq.github.io. This is how it looks like. For generating the dataset, we are going to use the same jsCoq you saw in the previous slide, and we're going to wrap it around the Docker Compose. Then, every time the user interacts with one of the arrows at the main panel, either by clicking on them or by using a shortcut on the keyboard, we're going to trigger an event to a Node.js instance. And then this Node.js instance is going to persist the event on a Mongo database. As a side note, at McGill University, a A similar strategy has been used to generate large datasets of OCaml programs coming from the Learn OCaml platform. I will leave a reference linked on the slides if you're interested. Every time the user performs one of the events at the main panel, it will generate a record on a Mongo database. This is how each record looks like. It has a timestamp to indicate when the user performed the action. It has all the content coming from the scratchpad, and it also has information about the user agent, namely what kind of browser the user was using when they performed the action. Every time there is a new event from the user, apart from what we just showed, we also generate other types of records on MongoDB. So we also collect the status of the running workers. We also collect all the information on the Goals tab, and we also collect all the information on the Messages tab. When we analyze the data, what can we do with it? First, we can use the data for educational purposes. Maybe we can analyze this data and draw conclusions about how can we improve jsCoq or similar tools in order to help students trying to learn Coq. Next, we can also use this data to detect bugs on the current interface. For example, if there is an issue with a certain browser, let's say Safari or any other browser, by analyzing this data, we might be able to detect that users using the current browser are actually experiencing some sort of weird behavior, either because they cannot move forward with the proof, or because we can also collect the information coming from the JavaScript log and then detect what is happening. We can also improve the visual aspect of the tool. For example, sometimes the arrows at the main panel can be too small, and if a certain user has some accessibility issues, they might not find it easy to use the menus that they see. So by analyzing the data from this large data set we are generating, we might be able to understand what these issues are and then improve the visual interface for the end user. Given that we're collecting a lot of events, we can technically reproduce every step that the user took as soon as they opened jsCoq. That means, in theory, we can try to understand the sequence of these events and then possibly improve the liveness of the whole environment. It is almost time to wrap up this talk, and I would like to give you a summary of what I just saw. So first, all the code for this modified version of jsCoq is available on GitHub. I will leave a link on the video so that you can follow it and maybe contribute to this project. Keep in mind, this is a work in progress. So at this time, there are many limitations. For example, if you're planning to use this generated data set with a group of students, currently there is no way to anonymize the information from the users. Also keep in mind that depending on how much data you generate, MongoDB is not going to be able to handle it all. And that's mainly because the way it is configured right now, it does not support excessively large data sets. Also keep in mind that the data that is being collected can change in the implementation on GitHub. And that's mainly because in data science projects, it is common to start analyzing the data and noticing something is missing. So again, this code is still not fully in a fully final version. The other technical limitation is that currently there is no automated way to keep the jsCoq image up to date, and that means I need to manually tweak it every time there is a new release. But apart from these technical issues, which are still being developed and adjusted, I hope you enjoy this idea and maybe embrace it and help us to create a large data set of proofs, which might be useful not only for our community, but also for different communities, for example, the machine learning community. Thanks for coming to this talk. If you want to talk about this idea of creating a data set of proofs, let me know and I will be around during the entire conference. Thanks again for joining, and those are some of the references that you can take a look at if you're interested. See you!